Hello from Rocket Lab's Mission Control Center in Auckland, New Zealand. We are live with a view of Electron on Pad B at Launch Complex 1 in Mahia. Today's launch is a dedicated mission for Earth imaging customer and longtime Rocket Lab partner, Synspective. If you've been following our missions for Synspective so far, you'll know that owls are a common theme, and today's launch is no different. Following in the footsteps of previous missions called The Owl's Night Begins, The Owl's Night Continues, and The Owl Spreads Its Wings, today's mission is called Owl Night Long. My name is Prachi Saknani, and I'll be with you live as we count down to our 45th Electron mission, scheduled for liftoff at 4:03 a.m. local time or 15:03 UTC. Now, speaking of being up all night long, our operators are on console and are tracking no issues for launch today. We are shooting for the last opportunity in today's window, but we still have plenty of opportunities over the coming days as a backup if we need to stand down for any reason. Today's launch is our fourth Electron mission for Synspective, starting with our partnership with them in 2020. All the satellites in Synspective's constellation are part of their Strix series. And for those avid bird watchers out there, you'll have recognized that Strix is a genus of owls, hence the owl-themed mission names. We first launched for Synspective in December 2020 with The Owl's Night Begins, our 17th mission, and a dedicated launch of Synspective's cutting-edge Earth observation satellite, Strix Alpha. Then, in February of 2022, we launched their Strix Beta satellite as part of our 24th Electron mission called The Owl's Night Continues. This mission was also the inaugural launch from Pad B at Launch Complex 1. The second pad at LC1 increased our responsive launch capabilities and allowed us to schedule more launches. We then continued our partnership with Synspective in September of 2022 with The Owl Spreads Its Wings, which carried a Strix 1 satellite. This was the first commercial synthetic aperture radar, or SAR, satellite in the series. Now, this launch was full of Rocket Lab milestones. It was our 30th Electron mission, it carried our 300th Rutherford engine, and Strix 1 was the 150th satellite we delivered to orbit. One thing that makes Synspective's payloads unique is that they're a little bit larger than the standard Electron fairing normally allows, and so our Electron engineers and designers developed a tailored fairing with notches to fit the corners of the Strix spacecraft. Just one of the many perks of flying dedicated on Electron and tailoring your mission to precise, customer-specific requirements. So let's take a closer look at Synspective's constellation. We mentioned earlier that this satellite series is called Strix, named after the owl. In many cultures, including Japan, the owl is a symbol of wisdom and luck. Owls have extraordinary night vision, the ability to see small details over long distances, and can even use sound to hunt. Similarly, Synspective's SAR technology uses the echo of radio waves to create 2- and 3-dimensional images with a millimeter level resolution of the Earth's surface. Because the technology does not rely on visual electromagnetic wavelengths, it can produce these high-resolution images regardless of cloud cover or daylight. The Strix satellites have provided images to assist in disaster response in all weather conditions, such as flooding and inclement weather systems, urban development and planning, and construction and infrastructure monitoring. As we approach T-minus 12 minutes, our operators will run through the go, no-go poll with this mission's launch director, Joseph Carpico. Let's throw it over to Mission Control to confirm that we are go for launch.
All operators, this is the LD on mission, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
RF.
RF is go.
MM.
MM is go.
LD sub.
LD is go.
The go, no-go sequence is complete. We are T-minus 11 minutes, 25 seconds and counting. We are go for terminal count. Auto sequence at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That's confirmation from Mission Control. All systems on Electron are healthy, and we are proceeding with the remainder of our count. T0 is targeted for 4:03 a.m. local time or 15:03 UTC. You see, today's Mission Control is filled with launch operators, but just a few days ago, they shared the room with our spacecraft operators as we conducted our very first spacecraft re-entry. We were bringing home an in-space manufacturing capsule for our partners Varda Space. For more than 8 months, the capsule lived happily on orbit, supported by a Rocket Lab designed and built spacecraft bus that provided power, communications, ground control, and attitude control. Inside the capsule, Varda was completing a world-first in-space manufacturing experiment by growing crystals for pharmaceutical products in orbit, hoping to grow them at a better quality than on Earth thanks to the reduced gravity environment. With the in-space manufacturing portion complete, our operators completed the final deorbit and re-entry positioning maneuvers on February 21st, and the capsule successfully touched down in the Utah desert shortly afterward. Let's take a bit of a look back at the development and execution of that mission.
Ground services configured. Antenna configured for TTC 04. Holding at 5 degrees elevation. Antenna released. AOS.
This is GNC on recovery net. The last maneuver exited nominally. The spacecraft is in deployment mode.
Capsule is on internal power.
1 minute to capsule set.
T-minus 10 seconds.
Deployment confirmed by GNC.
Expected parachute deployment.
VRCO has a camera visual confirmation on chute.
Approximate touchdown time is in 100 seconds.
And Varda recovery, please let us know when you have visuals in the capsule.
That is affirmative, and it is in visual by the recovery helicopter.
Copy all. Thanks, Scooter. Thank you so much for all your support and your ride.
Rock Lab MD signing off.
So grateful to be able to have worked with such an amazing team from Rocket Lab. Honestly, best of the best of everything we do. I've been working on this mission for a couple of years, so this is an incredible milestone to see mission end happen the way we designed it from day one. We got 3 more to go. 1 more is waiting for launch in the summer, so we're ready to do it all again.
What an incredible view, and what a way to conclude the mission. But that is not all. This was just the first of 4 spacecraft that we are building for Varda, with the second already built and ready for its upcoming launch date. Our Space Systems division is hard at work, not only building for Varda, but also building dozens of spacecraft for the Space Development Agency, MDA and Globalstar, NASA, and more. Speaking of all the spacecraft our divisions are building, we have a growing number of opportunities to join the team. At our headquarters in Long Beach, we are looking for new talents to help build spacecraft, radios, avionics, our Rutherford and Archimedes engines, and more. We've expanded our headquarters to meet the demands of our programs and need people like you. So why Rocket Lab? Let's see what some of our team members have to say.
Working here in Long Beach at Rocket Lab headquarters is great. It's a really dynamic environment, high energy. There's a lot of things going on every day. And so coming in, it's something where it's not always the same thing yet you do constantly. It's always something new, something challenging. And so that really keeps you on your toes and creates something that you want to come back to every day.
The stuff I'm working on is gonna directly, immediately help people and be there for people is the most cool potential of space, just realized directly. And that's super cool.
Knowing that some of our satellites will be going into the orbit of Venus one day, knowing that I'm an integral part of these missions gives me the drive to work on them.
We're trying to do things a lot faster than everybody else, including going to the moon, going to Mars. That brings with it a whole set of new things that we can do faster, things that we can do better than others. And that really inspires me because it opens up space to a whole new set of possibilities, use cases. My favorite Rocket Lab moment to date has been the re-entry of the Winnebago satellite. All of the work that went into being the first commercial satellite to re-enter on US soil. That's really cool. That's something nobody else has done.
We recently ran the first production tests on actual flight modules. And there was a bunch of us gathered around these plots and just watching the data come in.
It was an extensive process, kind of like the Trailblazer, proving that that module actually passed. That was probably my most exciting moment here.
So people should come to Rocket Lab because it's a unique environment. We're one of the few companies in the world that can do both the rocket side of things as well as the satellite side of things. And so you get a unique blend of a whole bunch of different skills, allows people to see different aspects.
I feel like people with broad skill sets are really valued. Even if you're not from space or if you've been in space for 15 years, you'll be able to contribute in a really cool and exciting way.
If California isn't your calling, we have openings available at our sites across North America and in New Zealand, including the buildup of our new site in Middle River, Maryland, where Neutron will come to life. If you're ready to launch your career and join our team, apply at rocketlabusa.com/careers now. We are moving towards the final stages before launch with T-minus 3.5 minutes on the clock. At T-minus 2 minutes or 2 minutes to terminal, Electron's autonomous flight computers will take over the countdown. Shortly after that 2-minute mark, we should hear the call that LOX loading is complete, which means that the vehicle is fully fueled and good to go. The next gate is the signal that the first and second stages are pressurized for launch. After that, we await the iconic 10-second countdown to liftoff. Let's listen into mission control for these final steps in the sequence.
Lock auto sequence and confirm.
Confirm locked.
And VCON, confirm all expected primary flight computer ASGOs are green.
All ASGOs are green.
This is the LD on mission. We are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
All avionics batteries switch to internal power. The vehicle is on internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purchase enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. And we have liftoff.
our 45th Electron is now in the air, having successfully lifted off the pad at Launch Complex 1. Synspective's Strix 3 satellite is on its way to space. The next critical stage in Electron's flight is Max Q, or maximum aerodynamic pressure. This is when the vehicle's velocity is at its maximum and the vehicle experiences the most amount of mechanical stress. Let's listen in for the call from Mission Control for when Electron clears that stage of flight.
Approaching Max Q. Cleared Max Q.
There we go. Electron has successfully passed through Max Q and at an altitude of just over 15 kilometers is well on its way to pass the Kármán line and enter space. The 9 sea-level Rutherford engines on the first stage are operating nominally, and we are approaching the next series of events in the mission. The first milestone after Max Q is MECO, or main engine cutoff, when those 9 engines throttle down before shutting down completely. This slows the vehicle down just a touch before the first and second stages separate, and once this is complete, the second stage space-optimized Rutherford engine ignites to take the payload and kickstage the rest of the way into orbit. These 3 events happen in quick succession, so let's keep an eye out and listen in for the calls from Mission Control.
Stand by for MECO in approximately 30 seconds.
"15 seconds to staging.
Entered burn light detect mode.
MECO confirmed.
Operation success.
Stage 2 ignition confirmed.
Done, done, and done. And with that, we've confirmed MECO, stage separation, and ignition of the space-optimized Rutherford engine on the second stage. At this point, as Electron has cleared most of the Earth's atmosphere, it can also jettison the fairing, as it is no longer needed to protect the payload.
Fairing jettison succeeded.
Guidance is nominal.
Electron's fairing has now been ejected, with the 2 pieces falling away to burn up in Earth's atmosphere. Electron's second stage is continuing nominally on its way to orbit, carrying the Synspective payload. The vehicle is currently at 132 kilometers altitude and reaching speeds of more than 9,000 kilometers an hour.
Stage 2 propulsion is nominal.
Electron's second stage continues onto orbit now at just over 9,700 kilometers an hour and at an altitude of 155 kilometers. The nozzle is glowing bright as we hit T+4 and a bit minutes into the flight for the Owl night-long mission for SAR imaging company Synspective. If you take a look at the panel on the right-hand side of your screen, you can see our propellant telemetry from Electron's Stage 2. Currently, we have about 60% of kerosene and about 60% of LOX remaining as we head into the next major milestone, the battery hot swap, a unique maneuver to Electron.
Guidance is nominal, 210 seconds remaining. Throttling down.
As I mentioned before, up next is a familiar mission milestone, the battery hot swap. This is where we take the depleted batteries powering the electric pump inside the second stage Rutherford engine and swap them out mid-flight for a fresh one to power us the rest of the way to orbit. If you watch closely, hopefully you'll catch the battery ejection and see it fall away from the stage. Keep an eye out for a silvery object on the right.
Hot swap successful.
Stage 2 propulsion holding nominal.
Battery jettison confirmed.
And there we go, successful battery hot swap. Electron is now traveling at over 16,000 kilometers an hour and is at an altitude of just over 200 kilometers. And with that hot swap completed, we are approaching second engine cutoff, or SECO. This is just a few minutes away, expected to occur at around T plus 9 minutes and 5 seconds. T plus 7 minutes into flight, an Electron is well on its way to orbit. The Stage 2 Rutherford engine is burning hot and bright with 25.8 kilonewtons of thrust being produced. The Rutherford engine, you may not have known, is named after famous New Zealand physicist Sir Ernest Rutherford, who pioneered many things, including being the first to split an atom.
HV battery discharge holding nominal.
If you take a look again at the right-hand side of your screen, you'll see Electron's Stage 2 and Kick Stage trajectory values tracking pretty closely to our estimates. Today's launch of Synspective's Strix 3 brings our satellite launch tally up to 178 satellites, with plenty more scheduled for this year in our launch manifest. This includes one coming up very soon from Launch Complex 2 in Virginia.
Into burnout detect mode.
All right, we're about 8.5 minutes into flight and quickly approaching SECO. Much like Kumiko earlier, the Rutherford engine on Electron's second stage will throttle back and shut down ahead of kick stage separation following a few seconds later. We're standing by now with mission control for those milestones.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
There it goes. The vacuum-optimized Rutherford engine has throttled down and the second stage has cleanly separated from the kick stage. For the next 50 minutes or so, the kick stage will enter a coast phase until it reaches the apogee of its elliptical orbit, or the furthest distance it will be from Earth. From here, the Curie engine will kick in to adjust the angle to a circular orbit. Once we reach Synspective's requested location in orbit, Strix 3 will be deployed from the kick stage, and that is the end of our role in the mission. Now, we won't have a live feed from the kick stage of payload deployment on this mission, but we will stay with you on the webcast to bring you a simulated view of payload deployment. We'll take a bit of a break on the webcast now, and we'll leave you with this graphic of the kick stage and its elliptical orbit above Earth. We'll be back with you closer to payload deployment to listen in on those final moments from mission control. Payload deployment is expected to take place at around T plus 53 minutes, so I'll see you back here very soon. Welcome back to the webcast for Rocket Lab's 45th Electron mission all night long. This launch has been a hoot. If you're just joining us, today's launch included a successful on-time liftoff at 4:03 a.m. New Zealand time and 15:03 UTC. A couple of minutes ago, we heard the kick stage with suspected Strix 3 spacecraft on board, approaching the apogee of its elliptical orbit. Our Curie engine then ignited, and we are now awaiting the shutdown of the Curie engine ahead of payload deployment. Let's check in with Mission Control.
Curie engine cutoff confirmed.
Apogee is 573 kilometers, perigee is 553 kilometers at an inclination of 97.558 degrees.
And a good shutdown of Curie. That small but mighty engine is relightable, allowing payload deployment to a variety of destinations, including a Hyper-Curie variant for interplanetary travel. Just under a minute now until payload deployment for Synspective.
Payload.
Payload deployment confirmed.
And there we have it. Synspective's Strix 3 satellite has been successfully deployed from the kick stage. Welcome to orbit, and congratulations to the Synspective team on our 4th mission together. To everyone at home, thank you for tuning in to watch our 45th Electron launch. This is a short farewell, as we'll be back in just a few days for our next launch, a dedicated mission for the NRO from Launch Complex 2 in Virginia. Until then, this is Rocket Lab Mission Control signing off.